So we are starting a series wherein I'll be discussing previous year questions being asked in either UPSC Civil Services Examination or UPSC Forest Services Examination. So first we are starting with topic of analytical geometry, and in that also today we are discussing direction ratios and direction cosine questions that are being asked in previous year. So let's get started with question number 1. So the question number says that there are straight lines whose direction cosine are given to us in this ratio: AL plus BM plus CN equals to 0 and UL square plus VM square plus WN square equals to 0. So they have given us as AL plus BM plus CN equals to 0. Let us name this equation as 1. And second equation is UL square plus VM square plus WN square equals to 0. Let's name it as equation 2. So they have asked that show that if the two straight lines whose direction ratios are in this relation, they will be parallel if this holds and perpendicular if this holds. So we know that two straight lines with which are parallel have same direction cosine ratios. So it is enough to show that if the quadratic equation which we will get by reducing it in two variable have discriminant 0, so using that we can find this relation. So let us do that. Let us reduce this equation into two variables to find out any relation. So let us just substitute value of L in this equation. So from equation 1 I got my L as minus BM plus CN upon A. So substituting this value of L in there, we got minus BM minus CN upon A square plus VM square plus WN square equals to 0. So now we can just simplify this equation and see what we get. B square M square plus C square N square plus B A square M square plus W A square N square equals to 0. Let's just club in coefficients of M square together and likewise for N square and Mn. Oh, here I missed a term. Here we'll also get 2BCMN. So if we club in coefficients of M square, we'll get UB square plus here also we have M square plus BA square M square plus 2BC UMN, and coefficients of N square are UC square plus WA square N square. Now if I just divide this whole thing with N square, I'll get, so basically this I'll get a quadratic equation where in M by N 2BCU M by N plus UC square plus WA square equals to 0. So this is basically a quadratic equation in M by N, and using this I can find value of discriminant. I can equate discriminant equals to 0, because only then if discriminant is 0, then only then I'll get these two equations as parallel, these two lines as parallel, because only then the direction ratios of these equation will be equal. So to calculate discriminant, I'll get 2BCU square minus 4 coefficient of M by N square, which is UB square plus VA square into UC square plus WA square equals to 0. I got this using B square minus 4AC equals to 0. This is discriminant if my equation is AX square plus BX plus C equals to 0. So if I simplify this equation, I'll get 4B square C square U square minus 4. Just simplifying this term, I'll get U square B square C square plus UV A square C square plus UW a square b square plus bw a raised 4 equals to 0. If I see that this term and this term are balances out each other, so I am left with uv a square c square plus uw a square b square plus bw a raised 4 equals to 0. Let us see what we need to. So we are supposed to prove that a square by u plus b square by v. Okay, we can take a square common, then we'll get uvc c square plus uwb square plus bw a square equals to 0. So from here I got uvc square plus uwb square plus bw a square equals to 0. So if I divide this whole term by uv and z w, so I got c square plus c square by w plus b square by v plus a square by u equals to 0. And this is what we are supposed to prove in the equation two straight lines are parallel. Now we know that two straight lines are perpendicular if their direction, product of their direction cosines is equals to 0. That is, if L1 L2 plus M1 M2 plus N1 N2 equals to 0. Now using this equation, let's name it as 3. We can get value of M1 by M1 N1 into M2 N2. So using this, here we know that product of roots in ax square plus bx plus c equals to 0 is equals to c by a. So using this formula in the above equation number 3, we'll get m1 by n1 dot m2 by n2. Here m1 by n1 and m2 by n2 I am considering as two roots of this quadratic equation, must be equals to c, this constant term, u c square plus w a square upon coefficient of m by n square. I got it as u b square plus v a square. So from here I will get m1 m2 upon u c square plus w a square equals to n1 n2 upon u b square plus v a square. Let us name this as equation 4. So if you observe the pattern, the initial two equations that we have is, let me just copy these equations. We have al plus bm plus cn equals to 0, al plus bm plus cn equals to 0, and ul square plus vm square plus wn square equals to 0. So if you observe the pattern here, so just by observing itself I can get value of L1 by L2, which will be equals to, so here for m1 by m2 we are basically just clubbing a square with w and c square with bu. Likewise for n1 n2 we are just clubbing a square by v and b square by u. So likewise for L we can just club b square by w, b square w plus c square v, which must be equals to m1 m2 upon u c square plus w a square, which must be equals to n1 n2 upon u b square plus v a square equals to, let us equate with it equals to some constant k. You can also calculate this value of L1 L2 by substituting, like value of m from this equation in this equation, then you will get L1 by N1 into L2 by N2. That will just increase the time. So just to reduce time, just observe the pattern and move ahead. So we know that two equations are perpendicular if L1 plus M1, L1 L2 plus M1 M2 plus N1 N2 equals to 0. So from this equation we can just get value of L1 L2 M1 M2 and N1 N2, and so from this equation substituting these values we get k b square w plus c square v plus k u c square plus w a square plus k u b square plus v a square equals to 0. We can get rid of this constant k, so we are left with b square w plus c square v plus u c square plus w a square plus u b square plus v a square equals to 0. So if we see that in question they have clubbed coefficients of a square, b square, c square together. So if we just club in coefficients of a square, here we have a square into w plus v plus b square into w plus u plus c square into u plus v equals to 0, and this is what we are supposed to prove in the question. Yeah, so this is the relation which holds when the two given straight lines are perpendicular to each other. So now let's move on to question number 2. So the question number 2, they have asked to prove that the angle between two straight lines whose direction cosines are given by this and this is pi by 3, that is 60 degree, if this relation holds. So we have a direct formula for finding angle between the straight lines. So we know that tan square theta must be equals to summation m1 must be equals to summation m1 n2 minus n2 m1 square upon summation L1 L2 whole square. So if we can just find value of m1 n2 minus n2 m1, then we can just substitute these values in this equation. So like we did in previous question, we'll just substitute value of one coefficient, one direction ratio from this equation in this equation, and then get a quadratic equation, and then we'll solve it forward. So later just substitute value of L from this equation in this equation. So the equation they have given to us are L plus m plus n equals to 0, and this is equation number 1, fmn plus gln plus hlm equals to 0. This is equation number 2. So from here I'll get L equals to minus fmn plus gn minus m minus n plus hm minus m minus n equals to 0. Let's just simplify it. We'll get fmn minus gmn minus gn square minus hm square minus hmn equals to 0. Let's just club in coefficients. So minus hm square minus gn square plus f minus g minus h mn equals to 0. So if I multiply this whole equation with minus, I'll get hm square plus gn square plus g plus h minus f mn equals to 0. So to reduce it to a quadratic equation, divided the whole equation by n square, m by n square plus g plus h minus f m by n plus g equals to 0. So this is a quadratic equation. From here I can get the sum of roots of this equation and product of roots. So let m1 by n1 comma m2 by n2 be roots of this equation. So from here I will get m1 by n1 plus m2 by n2 equals to minus coefficient of m by n, which is g plus h minus f upon coefficient of m by n square, which is h, which is equivalent to f minus g minus h upon h, and product I'll get m1 by n1 into m2 by n2, which is equivalent to g upon h. So using this I can easily calculate. If you observe that this thing is equivalent to m1 n2 plus n1 m2 upon n1 n2, which is equivalent to f minus g minus h upon h. But in tan theta we need to calculate m1 n2 minus n2 m1. So using this and this we can easily get that. So we know that m1 n2 minus m2 n1 square equals to m1 n2 plus m2 n1 square minus 4 m1 n2 m2 n1, which is equivalent to, we can just substitute value of this and this here. So we are left with, let us just equate with some constant k. So we'll get value of okay. So what we can do is we can just reduce it to relation m1 n2 plus n1 m2 upon f minus g minus h is equals to n1 n2 upon h, which is equivalent to k. So from here I can get value of m1 n2 plus n1 m2, which is equivalent to k f minus g minus h square minus 4 n1 and 2 value is hk, and m1 m2 value I'll get as gk. I got this value just by seeing the similarity in between this, and using that only I will get value of m1 and 2. Or you can just use this one, this equation here, you can get it equals to gh. So if we simplify it, we'll get, just taking k square common, f minus g minus h square minus 4gh, which is equivalent to k square f square plus g square plus h square minus 2fg plus 2gh minus 2fh minus 4gh, which is equivalent to k square f square plus g square plus h square minus 2 fg plus gh plus fh. Also in question, if you remember, they have given us this relation 1 by f plus 1 by g plus 1 by h equals to 0. So 1 by f plus 1 by g plus 1 by h equals to 0. If we take LCM, we'll get gh plus fh plus fg equals to 0. So we are substituting this value in this equation. So we'll get m1 n2 minus n2 m1 minus n1 m2 whole square equals to k square f square plus g square plus h square. Now we are also likewise we can calculate for L1 N2 minus L2 N1 square, which will be also equivalent to this thing, f square plus g square plus h square, and L1 M1 L1 M2 minus L2 M1 whole square, which will also be equal to this thing only, f square plus g square plus h square. Now from this equation, product of roots, I will get m1 by m2 upon n1 dot n2 equals to g by h. Yeah, g by h. So from here I will get m1 by m2 upon g equals to n1 by n2 upon h, which we have taken equals to k. We can take this equals to k and this equals to k because both involves this term, n1 by n2 upon h. So that's why we can take ratio of both sum and product equals to same thing. So from here I can calculate L1 plus L2. If we observe the similarity, we'll get this thing equals to L1 upon L2 f. So from here I can calculate L1 L2 plus M1 M2 plus N1 N2, which is equals to K F plus G plus H. So now finding the angle, which is tan square theta equals to summation m1 n2 minus n2 m1 whole square upon summation L1 L2 whole square. So this is equivalent to, from here we can just substitute these values, which is equivalent to 3a square f square plus g square plus h square upon k f plus g plus h whole square. We can easily get rid of k, which is we get it equivalent to f square plus g square plus h square upon f plus g plus h whole square. So we need to eliminate these values f, g and h as well. Okay, so we know that fg plus gh plus fh equals to 0. We got it from this equation. So we can just add 2 times of this equation herein to form a whole square. So we got tan square theta equals to 3 f square plus g square plus h square plus 2 fg plus gh plus fh. We can add this because this term is equivalent to 0 divided by f plus g plus h whole square. Now this is just simplification. This whole term is equals to f plus g plus h whole square upon f plus g plus h whole square. We can just balance this thing out. So what we got is tan square theta equals to 3. So from here I got my tan theta equals to under 2 3, which is equals to 10 pi by 3. So I got my theta as pi by 3. So pi by 3 is the angle which these two lines are forming, whose direction ratio are given to us, direction cosines are given to us. So we are done with question number 2 as well. So now let's move on to question number 3. So the question number 3 says that a line makes angle alpha, beta, gamma and delta with 4 diagonals of a cube. Show that cos square alpha plus cos square beta plus cos square gamma plus cos square delta vector is equals to 4/3. So just let us assume a line with some random direction ratios. So there is a line with direction ratios L, M and N. So let us just draw a cube to see the 4 diagonals and their direction ratios. This is my x-axis, this is my y-axis, and this one is my z-axis. So if I draw a cube here, so this is my cube. Let length of each side be A. So if length of each side is 8, then I can easily get vertices of this equation. So let me name it as A. This will be 0, A 0. This is B. This will be A 0. Here C, A 0 0. This I am naming as O 0 0 0. And this one as E 0 0 A. F, it will be A 0 A. This one as G, it will be A. And I guess we missed D. Yeah, this one will be D, and it will be 0 0 A. So if we observe that diagonal of the cubes are 4 diagonals, we are supposed to take all 4 diagonals. So first diagonal we can take as OG. Diagonals of cube are OG, then AF. Another one can be BE, and we can take last one as I guess CD. Yeah, CD. So we'll just calculate. So they have given us angles of alpha, beta, gamma and delta. So we'll just find angles between these equations. So let this line forms angle alpha with OG. So cos alpha will be, so let's first find out direction ratios of OG. So direction ratios of OG will just subtract these vertices from value of these vertices from each other. So we'll get A minus 0, that is A, again A minus 0, A and A. We got direction ratios of OG as A. Its direction cosines. So cos alpha equals to, here also its direction cosines. So we can calculate cos alpha by AL plus AM plus AN and divided by under root A square plus A square plus A square under root L square plus M square plus N square, which is equivalent to AL plus AM plus AN upon under root 3A square under root L square plus M square plus N square, which is further equivalent to L plus M plus N upon under root 3 under root L square plus M square plus N square. Likewise, we can calculate angle with other diagonals as well. So let's see direction cosines of AF. A and F will be A minus 0, that is A 0 minus a, that is minus a, and again a minus here, that is again a. So let us this make angle beta with the line. So cos beta equals to al minus am plus an upon under root 3 a square upon under root l square plus m square plus n square, and on simplifying we'll get L minus m plus n upon under root 3 under root L square plus m square plus n square. Now we can find direction cosines of BE, which are, this one is my B and this one is my E, which are a minus 0 as a minus 0 as a, and 0 minus a minus a. So if the given line makes angle gamma with BE, then cos gamma equals to AL plus AM minus AN upon under root 3 a square under root L square plus m square plus n square. On simplifying we'll get L plus m minus n upon under root 3 under root L square plus m square plus n square. Likewise, direction cosines of a CD. And this point is my C and this one is D. So direction cosines of CD are 0 minus a as minus a minus 0 as a minus 0 as a. So if delta is the angle that is line making with diagonal CD, so we'll get cos delta as minus LA plus MA plus NA upon under root 3 a square under root L square plus m square plus n square. So on simplifying we'll get minus L plus m plus n upon under root 3 under root L square plus m square plus n square. So we are supposed to calculate value of cos square alpha plus cos square beta plus cos square gamma plus cos square delta. So we'll just substitute values of these. So we'll get cos square alpha plus cos square beta plus cos square gamma plus cos square delta is equals to cos alpha is L plus m plus n upon under root 3 L square plus m square plus n square whole square plus cos beta is L minus m plus n upon under root 3 L square plus m square plus n square whole square plus L plus m minus n upon under root 3 L plus L square plus m square plus n square whole square plus minus L plus m plus n upon under root 3 L square plus m square plus n square whole square. So if we simplify this, we'll get in denominator we'll get 3 L square plus m square plus n square, and in numerator we'll just open these whole squares. So let's start with first one. We'll get L square plus m square plus n square plus 2lm plus 2mn plus 2ln plus L square plus m square plus n square minus 2lm minus 2mn plus 2ln plus L square plus m square plus n square minus 2lm plus 2lm minus 2mn minus 2ln plus L square plus m square plus n square minus 2lm plus 2mn minus 2ln. So if we just observe that, we will get 4 of L square plus m square plus n square upon, we can just balance out terms, 2lm, this one balances out this one, 2mn balances out this one. Likewise, this 2ln balances out this one, and this 2ln balances out this one. 2lm, this one balances out this one, and 2mn, this one balances out this one. Yeah, so we are only left with 4 of L square plus M square plus N square, and in denominator we have 3 of L square plus M square plus N square, which is equals to 4 by 3, and that's what we are supposed to prove. So now let's move on to the last question of today, which is we are supposed to find the angle between the lines whose direction cosines are given to us. So they have given us two relations in between direction cosines of two lines. So the two lines relations are L plus M plus N equals to 0 and 2LM plus 2LN minus MN equals to 0. So we can just substitute value of one of these into this to reduce it to a quadratic equation. So let us just substitute value of N. So N equals to minus of L plus M. So if we put this value of N here, we'll get 2LM plus 2L minus L minus M into minus L minus M, which is equivalent to 0. If we just simplify it, we'll get 2LM minus 2L square minus 2LM plus ML plus M square equals to 0. This term balances out this one, so we are left with 2L square minus ML minus M square equals to 0. We can write this as 2L square minus 2ML plus ML minus M square equals to 0. I just added and subtracted 1 ML in the above equation and I landed here. So if we just simplify it, 2L L minus M plus M L minus M equals to 0, then L minus M 2L plus M equals to 0. So this implies L equals to M or M equals to minus 2L. So we know that if there are two cases, if L equals to M, then from here N equals to minus of L plus L, which is equals to minus 2L. So from here I got my ratios as L upon 1 equals to M upon 1 equals to N upon minus 2. So this is a direction ratio of one straight line. Let me name it as star. Now if my M is equals to minus 2L, then I'll get my N as minus of L plus minus 2L. From here I got my N as minus of minus L, which is equals to L. So from here I got my direction ratios as L upon 1 equals to M upon minus 2 equals to N upon 1. So this is direction ratio of second equation. Let me name it as star. So we got direction ratios of two straight lines whose relation is given to us in the question. So we know that angle between two straight lines is cos theta equals to L1 L2 plus M1 M2 plus N1 N2 divided by summation L1 square plus M1 square plus N1 square under root summation L2 square plus M2 square plus N2 square. So if we I just equate this equation with, let's say, K1 and this one with, let's say, K2, and substitute value of LMN in the equation, I'll get cos theta equals to K1 into K2 plus K1 into minus 2 K2 plus minus 2 K1 into K2 divided by under root k1 square plus k1 square plus 4k1 square and under root k2 square plus 4k2 square plus k2 square. On simplifying, I'll get 1 minus 2 upon 4, 5, 6 under root 6 and under root 6, which is equivalent to minus 3 upon 6, which is equals to minus 1 by 2. So from here I got my theta as theta equals to 120 degree. When theta equals to 120 degree, cos x value is minus 1 by 2. So the angle between two lines is 120 degree. So that's all for today. Now tomorrow we'll discuss questions of planes that are being asked in previous year. Thank you.